In this lecture today we'll be discussing about the concept of probability distributions. So probability distributions are generally a function showing all possible values or interval of values of the data variable and how often they occur. This is a very important math, stat, or data science concept that we need to grasp moving forward. So let's start with the idea that we already have seen in the other video, is the tossing of a coin. So tossing of a coin, you have two possible outcomes, the head and the tail. And let's assume that the coin was a fair coin. So you have two possible outcomes, head and tail, and their corresponding values will be 1/2 for each outcome. In every probability distribution, you will come up with a figure like this. So the x-axis will represent or show the possible outcomes. For example, for the coin tossing example, you have two outcomes, head and tail, and the y-axis will show the corresponding probabilities for each outcome. So you can see for this example we have head and tail each with half or 0.5 probability values. This is an example of a simple but a complete probability distribution. There are a lot of different probability distributions that you will be dealing with in your coming days, and here we won't be covering all, but a few very important distributions. The first one is the uniform distribution, and you will have one uniform distribution for the discrete case, and you will have the same for the continuous variable case. And then we will cover another binary distribution that is called a binomial distribution. And if you understand the binomial distribution, then you can quickly connect to a more general discrete probability distribution of the same nature, what we call multinomial distribution. But here we will just focus on this binary or binomial distribution. And then we will cover one continuous and a very important probability distribution that you will encounter in many of our cases that we'll be studying, what we call normal or a Gaussian distribution. So let's start with the discrete uniform distribution. Quite simple. So your x-axis will be all the possible outcomes of a discrete variable, and in the y-axis you will have their probabilities, but as it is an uniform distribution for a variable with n possible outcomes, the corresponding probability for each variable will be 1/n. So we have already seen an example for the binary case. If you have a case with 6 outcomes, for example, throwing a dice, you will have 6 values in the x-axis, and their corresponding probability values will be 1/6 for each outcomes. Examples of discrete uniform distribution: tossing a fair coin or throwing a dice. The examples we have already talked about. Now, before going to the continuous uniform case, I'll show an example of a continuous non-uniform case. Continuous but non-uniform distribution. And why? Because if you understand this, then you can quickly connect back to the continuous uniform case using a counter example. And one example of this continuous non-uniform distribution is your grade point. So we are talking about the accumulated points, and the range is between 0 and 100, and it can be any values between 0 and 100. So that's why the values are continuous. So let's plot that into the probability distribution graph, and we can see that the x-axis values are starting from 0 to all the way to 100, And even if you look at their discrete definition of your grades, the range is different for F grade when you compare to the other grades, and the y-axis values are also different. So we don't expect all the students will get equal grades. Or the other way, we cannot expect all the grades that we have defined will have equal number of students getting that grade. Here we are showing 1, 2, 3, 4, and 5 categories or bins, but the continuous values, which is in the range of 0 and 100, will have clearly not uniform values. So this is a perfect example of a non-uniform continuous distribution. And now I will show an example of a continuous uniform distribution. So you can see that the pattern is quite similar to the discrete uniform distribution. The only difference, if the value range is between A and B, then the denominator will be B minus A. One popular example is throwing a dirt. If I'm playing this game and as I'm not an expert, my throw of the dirt will land on like any point within the board. So this is a example of a continuous uniform distribution. That's all for this part. In the next part, we'll be discussing about continuous Gaussian distribution. Yeah, thank you.